Okay, this question, when you first look at it, you may fall into a trap. Let me just point to some of the things here that you want to watch out for. This doesn't say f of x. This doesn't say probability density function. These are individual values of x. And this says discrete random variable. Although we're presented with a function with a bracket on it, this is not a continuous random variable question. It's discrete, and this is just an alternative method of presentation to the more familiar probability table where you've got the x values and you've got their probabilities on the next line down. In fact, one thing you might like to do is just turn that into a table. Here are the possible outcomes with non-zero probability, so you can just put in the numbers from 1 up to 6 in the top of your table and fill in their probabilities, and then it may look a lot more familiar. So then in part A we need the probability of being greater than or equal to 5, so you just need to total up the relevant probabilities. Then we're on to the expectation and variance, not of x, but 1 over x. So there's absolutely no need to find the expectation and variance of x. Remember, non-linear functions like 1 over x you can't get directly from the expectation variance of x. So I'd swap over entirely here to the distribution of 1 over x. So if you set up a new table, retabulate 1 over x with the probabilities, and then use your normal method for expectation and variance. The formulas are on page 11 of your blue formula book if you've forgotten them, but that should be straightforward discrete random variable stuff. The variable just happens to be 1 over x instead of your original x. And part C, don't neglect this, is another re-entry point. You don't have to have done any of the previous part of the question to do this. If you set up the value of A, it's the area of a rectangle. Here's the length and width, so you can get A in terms of x, and A turns out to be a linear function of 1 over x. So A will be a number plus another number times 1 over x. And since you already know the mean and variance of 1 over x, you can just use linear scaling to get the mean and variance of A for 5 dead easy marks.